Hello everyone. This is lecture series for previous year question. In this lecture series, I will cover means previous year questions. So first question, the given limit is limit x tending to 0 positive x box function 1 by x plus 2 by x 2 by x box plus 3 by x plus so on up to p by x. Clear? This is box function means greatest integer function, and then minus of minus x square box 1 by x square plus box 2 square by x square and so on up to 9 square by x square, which is greater than equal to 1. Okay, so what is the value of this limit you have to find. So I want to say before going to solve, this is the formula. Box x equal to, I can write box x means greatest integer function plus fractional function. Clear? So also I am writing, also I can write box x equal to x minus fractional part. Clear? So according to the given limit, I can write limit x tending to 0 positive x as it is, and in the bracket box function I can write instead of box 1 by x minus fractional part of x, yes or no, 1 by x. Same way 2 by x minus fractional of 2 by x. Clear? So up to then p by x minus fractional part of p by x. Now minus x square same as 1 by x square minus fractional part of 1 by x square plus 2 square by x square fractional part of 2 square by x square and so on up to 9 square. Okay, up to 9 square I'm writing 9 square by x square minus 9 square by x square. This is greater than equal to 1. Now limit x tending to 0 positive. Uh, what is the range of curl bracket x? This is the range. The range of this is 0 less than equal to x less than 1. That means this is a finite. That's why why I am telling that if I multiply this with x, so what will happen? X multiply with 1 by x, that means 1 become, then x multiply with this term plus 2, same way up to p. Clear? Now if I x multiply with this term, so minus x into 1 by x curly bracket, same way 2 by x curly bracket, same so on up to p by x curly bracket. Clear? Similar way the second term, second expression, if I multiply with x square, then that become 1 plus 2 square up to n 9 square. Clear? Now next minus x square, if I take minus then positive, here 1 by x square plus 2 square by x square so 1 plus 9 square by x square. Clear up to this? This is greater than equal to 1. Now this is up to p. So what is the natural number sum formula? The sum formula was limit x tending to 0 p into p plus 1 by 2. Clear? And this term give you 0 because x is going to 0, and the in the bracket case, in this bracket, this bracket part is a finite number because the range of curly means fractional part is in between 0 to 1. That means this sum of this should be a finite number. Clear? So x into some finite number and x also going to 0. That means this total term becomes 0. So minus 0 if I apply limit. And same way, what is the sum of this number? The sum of this number was, that was the formula, 1 square plus 2 square plus 3 square plus so on plus n square. The formula was n into n plus 1 into 2n plus 1 by 6. This was my formula. So here n equal to 9. Okay, so just put that 9 value only, minus 9 into 9 plus 1 into 2 into 9 plus 1. So 9 into 10 into 19 by 6. And same way this part becomes 0. Okay, same concept. So this is plus 0 greater than equal to 1. So after that I can write p into p plus 1 by 2, minus this should be cutted, 3 to 6, 3 to 5. So maybe particular 285, 5 3s are 15, and then 285 maybe greater than equal to 1. So now I can write p into p plus 1 by 2 greater than equal to 286. Clear? So from here p into p plus 1 greater than equal to 2 286 into 2. Okay, and also then I have to find the value of p na. So look here, 286 into 2 I can write to 22 into 26. Okay, this is I can write also. So tell me one thing, what of the p value can be satisfy this equation? P into p plus 1 greater than equal to 22 into 26. Clear? So if I take p equal to 22, least value at least p equal to 22, na, p start from 22 if you assume. So if p equal to 22 into 23, is this multiplication become means greater than 22 into 26? Not now. If you take 22, sorry, p equal to 23, if you take 23 into 24, is this greater than with means greater than of this value? This value. Just check yourself. P equal to 24 is satisfying this inequality. So answer should be p equal to 24. Sorry, this is main 2025 PYQ. Clear? Now next question. Now next question. The given function is this is the given limit. I have to solve the first this limit. Okay. So limit n tending to infinity, given that summation tan of something, take first tan as a common, tan x by 2 to the power r plus 1, this as a common, then remaining part 1 plus tan square x by 2 to the power r plus 1 divided by 1 minus tan square x by 2 to the power r plus 1. Okay, so we know the one formula, cos x formula was 1 minus tan square x by 2 by 1 plus tan square x by 2. Okay, this is my formula. So if I apply here, this is 1 minus tan square in the denominator and 1 plus in the upper case means numerator. So that formula if I apply, then summation tan of x by 2 to the power r plus 1 divided by that, if I apply that formula, then what will happen, cos x 2x should be there, na. So that's why x by 2 to the power r should be there, not r plus 1, because whenever x by 2 was there, then the cos become x only. So cos x by 2 to the power, I think clear. So now after that I can write limit n tending to infinity, tan x x by 2 to the power r plus 1, I can write sin x by 2 to the power r plus 1 divided by cos x by 2 to the power r plus 1 into cos of x by 2 to the power r, 2 to the power r. Now next step, limit n tending to infinity. Okay, now tell me one thing, I can write here, this is sin x by 2 to the power r plus 1. Okay, so I can write sin of x by 2 to the power r plus 1. Okay, minus x by 2 to the power r. I think that should be r plus 1. Okay, to x by 2 to the power r should be there. Okay, 1 minute. Let me write x by 2 to the power r minus x by 2 to the power r plus 1. Okay, can I write this? Okay, check your verify. If I take LCM, then maybe yes. Oh yes, obviously is right. This is right. So cos, as it is, cos x by 2 to the power r plus 1 into cos of x by 2 to the power r. Okay, now apply above a sin a minus b formula. So sin a cos b, this is 2 to the power r. Okay, sin a cos b minus cos a sin b, cos a sin b. Clear? This formula clear? So below case cos of x by 2 to the power r plus 1 into cos of x by 2 to the power r. So after that, limit n tending to infinity, summation of if I means separate this thing. So from this part, maybe this and this should be cutted. So 10 x by 2 to the power r minus uh, this should be cutted with this. Okay, that means 10 x by 2 to the power r plus 1. Okay, then r start from r equal to maybe 0 to n, 0 to n. So from here, limit n tending to infinity, r 0 to n means 10 x minus 10 x by 2. Same way, plus then if you put r equal to 1, then 10 x by 2 minus 10 x by 2 square. Same way. Okay, same way up to infinity. So every term cutted with next term. Okay, cutted with next term. Similarly, that means there should be remaining two terms. Which one? First one is tan x and second one is tan of x by 2 to the power n. Clear? So limit n tending to infinity. If I apply n tending to infinity, that becomes, this become give you 1 by infinity. That means 0. Tan 0 what? 0. So that the limiting value is tan x. Clear? Up to sorry, up to here clear? So corresponding functional value f of x equal to 10x. Now you have to find the value of limit x tending to 0. 1 minute, I am doing here. Limit x tending to 0, e to the power x minus e to the power tan x, because of f of x equal to tan x and x minus tan x. Okay, if you put x equal to 0, that becomes 0 by 0 form. Yes, so I have to apply L'Hospital here. Limit x tending to 0, so e to the power x derivative is also e to the power x, and e to the power tan x derivative, e to the power tan x into tan x derivative secant square x by 1 minus secant square x. Okay, if I put again a 0, so that becomes sec 0 what? 1 maybe. Yes, 1. Okay, sorry. So 1 e to the power 0, this is, am I right? Yes, maybe 0 by 0 form. Again maybe 0 by 0 form. So again do derivative again. So limit x tending to 0, e to the power x as it is, minus this term e to the power tan x and secant square x whole square minus e to the power tan x add as it is, and 2 secant x, that becomes, that should be our derivative. Okay, sorry for this. Okay, that means one derivative is 0 minus 2 secant square x into tan x, again 0 by 0. Okay, okay, let me do clearly for this limit. Okay, let me try here, something confusion making. Okay, let me verify. Okay, okay, I am writing here. Limit limit x tending to, let me check once, x tending to 0 now. Okay, x tending to 0, e to the power x minus e to the power tan x divided by 1 minus, sorry, x minus tan x. I think clear. This is okay. I have to find the value of this. So this becomes 0 by 0 form. 0 by 0 form maybe. So I can apply L hospital rule here. So limit. Okay. In this way, I can also solve. If I take e to the power x as a common, e to the power tan x take as a common, e to the power tan x common, e to the power tan x, e to the power x minus tan x minus 1 by x minus tan x. Okay. After this step, e to the power tan x value, if I put x tending to 0, that becomes 1. Okay. So leave this e to the power tan x minus tan x minus 1 divided by x minus tan x. From here, this is also check 0 by 0 form. I can apply L hospital rule here. So limit x tending to 0, e to the power x minus tan x derivative 1 minus secant square x. Okay. So from here, this is 1 minus also secant square x. Clear? Because of this is 0 by 0 form, so this should be cutted. Apply here, this is equal to 1, so the answer is 1. Clear? Next question, limit x tending to 0, cosec x square root of 2 cos square x plus 3 cos x minus square root of cos square x plus sin x plus 4. Okay, what is the value of these? Options are 0, second option 1 by root 15, third 1 by 2 root 15, fourth minus 1 by 2 root 5. Clear? So this is main 2025. Now try to solve this question. Okay, the given limit is limit x tending to 0. I can write in this way: square root of 2 cos square x plus 3 cos x minus square root of cos square x plus sin x plus 4 divided by sin x. Okay, look here, if I put x equal to 0 here, then that becomes 0 by 0 form. Yes or no? Yes. So also after that, I want to rationalization like that. This is square root of something minus something, so I can write in this way. Okay, I am giving demo here. Like, assume I have x tending to 0, root x minus root a, assume by something b, assume. So I am trying to do look like this: root x minus root a as it is, then multiply with root x plus root a. I think this process you know, b by root x plus root a. Okay, so in the numerator and denominator, I am applying multiplying with the positive sign. Okay, so that's why this become a minus b, a plus b, so a square minus b square, and the remaining but as it is. Okay, same I am applying here. So if I apply with positive sign, so that become a square minus b square. That means I can write 2 cos square x plus 3 cos x a square minus b square. B means what? This total cos square x plus sin x plus 4. Clear? And the below case, sin x into the positive sign with positive sign. That means I am erasing these things. Okay, I think clear this process. So square root of 2 cos square x plus 3 cos x plus square root of cos square x plus sin x plus 4. Clear? Now from here, limit x tending to 0, this becomes 2 cos square x minus cos square x 3 cos x plus 3 cos x minus sin x minus 4 divided by as it is, whatever this here. Okay, so now tell me one thing. I can write in the next step limit x tending to 0, cos square x plus 3 cos x minus sin x minus 4 divided by sin x into multiply with it. Then I can also transfer this limit now. limit extending to 0, 1 by that part, this part I am writing total. Okay, so the left side, for this left side limit, this is check, you can verify, this is 0 by 0 form. Clear? So you have to apply L hospital rule. To apply L hospital rule, you have to derivative up and down. So 2 cos square x, derivative of 2 cos x into minus sin x, and derivative of cos x is, this is minus 3 sin x minus cos x divided by cos x. Okay, and the this limit, this part limit extending to 0, put here, put here. If you put here, this is cos 0 becomes 1, so root 5 plus root 5, you can verify yourself. Okay, so 1 by 2 root 5 will come. Clear? Now apply 0 here, so this becomes 0, this becomes 0, this becomes minus 1. So minus 1, 1 by into 1 by 2 root 5, that means minus 1 by 2 root 5 is your correct answer. This is your correct answer for one. Okay, now next question. Limit extending to infinity, 2x square minus 3x plus 5 divided by 3x square plus 5x plus 4 and 3x minus 1 whole to the power x by 2, and this is 3x plus 2 whole to the power x and square root. Okay, is equal to options are uh, 2 by root 3e, second option 2e by root 3, third 2 by, sorry, 2 by 3 root e, and fourth one 2e by 3. This is also 2025 JMN. Clear? So how to solve this problem? Given limit extending to infinity. Uh, I am writing in part wise, like 2x square minus 3x plus 5 divided by 3x square plus 5x plus 4 into limit, I can write now. So limit extending to infinity, 3x minus 1 whole to the power x by 2, and look here, the below part also same thing like that, 3x plus 2 whole to the power x by 2 I can write. Yes, so look here, if I put extending to infinity, this is infinity by infinity form, this above. So I have to apply the L hospital rule. So limit x tending to infinity, just apply L hospital means derivative, 4x minus 3 divided by 6x plus 5. Okay, again this is infinite by infinite. Now limit this part, limit x tending to infinity, I can write, look here, 3x minus 1 plus 3 divided by 3x, 3x minus 1 whole to the power x by 2. Yes or no? Check, means verify yourself. So this part, now limit x tending to infinity, this become again infinite by infinite form, so 4 by 6 after derivative. So after derivative, then this part limit extending to infinity, 1 by, this part I can write 1 plus 3 by 3x minus 1 whole to the power x by 2. Yes or no? Check yourself. This is look like 1 to the power infinity form, this part 1 to the power infinity form. So 1 to the power infinity form means that become e value na, like this is 4 by 6, 4 by 6, what I am writing here, 2 by 3, 2 by 3 into this part I can write in this way, look here, x by 2 na, I can write x here and whole to the power 1 by 2. Okay, and this limit become means e na, you know that formula, if you have 1 plus 1 by x limit x tending to 0, like infinity, this, so this is 1 to the power infinity form, so that value is equal to e now. Clear that formula? So now this become e, so this become e, so 1 by square root e, because half was there now, so square root e, so 2 by 3 root e is your correct option. 2 by 3 root e, where 2 by where correct. Now next question, limit extending to infinity e by 1 minus e exponential 1 by e minus x by x plus 1 whole to the power x equal to alpha. Okay, then you have to find the value of log of alpha divided by 1 plus log alpha. This is equal to first option e inverse, second option e square, third option e to the power minus 2, and fourth one e. So how to find the limit? First of all, the given limit is limit x tending to infinity. This is e by 1 minus e, and if I take LCM, the second part, e x plus 1 above x plus 1 minus e of x whole to the power x. Now step 2, limit x tending to infinity. E should be cutted from here, and look here, if I take like x plus 1 minus ex divided by 1 minus e x plus 1 whole to the power x. Okay, now limit x tending to infinity, partwise division. If I this means this part by this total, so what, 1 minute, 1 by 1 minus e minus this part by this part, so ex by x plus 1 1 minus e. Clear? So from here I can write, okay, let me check once, 1 minus e. Okay, okay, okay. So limit x tending to infinity 1 by 1 minus e. From here I can write x plus 1 minus 1 e divided by x plus 1 1 minus e. Yes, obviously I can write. So from here, next step, x tending to infinity. Let me do first 1 minus e minus partwise division. So e by 1 minus e, this become, and plus e by x plus 1 1 minus e. Verify yourself. Okay, now limit x tending to infinity. This become 1 plus e by x plus 1 1 minus e whole to the power x. Okay, look here, check here, if I put x tending to infinity here, so 1 to the power infinity form is there. Clear? So 1 to the power infinity form, that means this is equal to the form. Okay, how to solve? 1 minute. Take y equal to 1 plus e by x plus 1 1 minus e whole to the power x. Take log both side, log y equal to, so x log of these things 1 plus e by x plus 1 1 minus e. Clear? So I can write limit x tending to infinity log of whatever by 1 by x I can write. So look here, if I put x equal to infinity here, so this is 0 by 0 form. Check, 0 by 0 form, so I have to apply L'Hospital here. So log of these things, the derivative of log of these things, 1 by 1 plus e by x plus 1 1 minus e. Clear? Because of log of something, this is something now. So and also I have to derivative of these things. So derivative of these things is e by 1 minus e minus 1 by x plus 1 whole square. You can do yourself. Okay, just you have to do derivative only, and the below case minus 1 by x square. Now what will happen, if I put here this become outside e by 1 minus e, and this become 1, this limit become 1. I am telling you that this is become 1 always, and this outside, and I have to do this for this minus minus cut it, and this is x square by 1 plus x whole square limit x tending to infinity. Am I correct? E by 1 minus e, from here limit x tending to infinity, I can write 1 by 1 plus 1 by x whole square. Yes or no? So that becomes tending to 1. This term becomes 1. So this is equal to e by 1 minus e. So log of y equal to this. So y equal to, I can write e to the power of 1 minute, e to the power of e by 1 minus e. This is our actual required limit. So, and I have to find the value of where log of alpha by 1 plus log alpha. That means this is equal to alpha, na? So I have to find log of alpha means what? E to the power of e to the power, sorry, 1 minus is this by 1 plus log of e to the power of e by 1 minus e. So that becomes e by 1 minus e by 1 plus e by 1 minus e. So actually e should be, e answer will come. Yes, yes, e answer came. Why? I don't know. E options there. Okay. Fourth one is correct option. Okay, correct. This is also JMN 2025.